Okay, Kramers rule. So this is our matrix, this are our equations, and here is the matrix of the left-hand side. So let's call it the variable side. Is that okay if I call it the variable side? So you can see what I did. I took those numbers. This side we're going to call the constant side. Okay, so if we make some diagonals, I'm going to multiply this diagonal. So 2 times -2 is -4. And 4 times -3 is -12. Okay, I hope I'm going to do this right, but I think it's going to be the down diagonal subtract the up diagonal. Okay, now we're going to do the, sorry, I just want to make some room here on this part. We're going to do the determinant. This is the D, determinant. I don't know if I use that word, determinant. The determinant X. So what does that mean? Replace the X coefficients with the constants. So this is not going to be 2 anymore, it's just going to be a 3. I'm replacing it with the constant. Then this is still a -3 because it stays. Replace the X coefficient with the constant, so 10 goes there. Constant is 10. And this is still -2. So there's a diagonal, there's a diagonal. So multiply the down diagonal, -6. Multiply the up diagonal, -30. So the down subtract the up gets me to 24. And then we're going to do the same thing with y. So if I give my matrix, I'm going to leave the x alone. So there's a 2 there and there's a 4. I'm going to leave the x alone now. And this time I'm going to replace the y stuff with 3 and 10. Multiply diagonals. So 20, 12, 20 subtract 12 equals 8. Therefore, the solution to x is determinant x divided by determinant a. So 24 divided by 8, so x equals 3 is the solution. And then y would be the determinant y, so 8 divided by 8, so y equals 1. Should we check if we're correct? Let's check. So if x was 3 and y was 1, this would be 2 times 3, so 6, minus 3 times 1. Yep, that works. If x was 3, this would be 12. And if this y was 1, this would be subtract 2 equals 10. Yeah, we're right. Okay, so let's try it again. Okay, give me the determinant of A. That's what we're going to do first. So I'm going to write 3, negative 2, 1, 1, 2, negative 2, 1, 1, negative 4. Okay, this one's a little bit different now. Because there's 3, we have to make diagonals with 3. So this one works. But do you see how this diagonal only has 2 components? That's not good. So what I'm going to do, I'm going to draw a line like that, and I'm just going to start repeating this over. 3, negative 2, and 1. 1, 2, negative 2, 1, 1, negative 4. Okay, so there's all my down diagonals now. Okay, so let's multiply. 3 times 2 times negative 4 is negative 24. Negative 2 times 1 is 4. 1 times 1 times 1 is 1. I'm going to add those together, which is negative 19.
Why don't you do the bottom 2?
These ones?
Yeah.
Because I can't, how do I connect 3 things here? Oh, which one am I talking about? Like this?
Yeah. You just don't have to.
I don't. There's no 3 connectors. You have to have 3 things when you multiply. And I can't throw something down here. Okay, we're going to go the other way. So there's my first diagonal. Connect the 3, connecting 3, connecting 3. Okay, if you want, these will never ever get used. So you'll see me not write all that stuff later. Okay, so we get a 2, a negative 6, and a positive 8. To subtract 6 plus 8 is 4. Okay, the down subtract the up. So determinant A equals negative 19 subtract the up, which is negative 23. Okay, determinant of x. Okay, remember what to do. Out of all the x numbers, replace them with the constants. So 9, negative 5, and negative 2 go into the x spots now instead. So replace the x's with the constants. Okay, and then I'm going to repeat a 9 and a negative 2. I'm going to repeat a 5. So, I mean, you can repeat them all, but I end up only using these ones. Those 2, that one, and those 2. Okay, 3 diagonals. Okay, work on your numbers and then I'll pause my video here and let's get our numbers. Okay, so here's my numbers. On the downs, I got -72, -8, -5. Then I added, and that all down came out to -85. Numbers match. Top diagonals, I got -4, -18, and -40. Add. That was -62. Good? Okay, so determinant x equals the downs minus the ups. The downs minus the ups, which ends up being -23, right? Yeah. So my conclusion is x equals this determinant divided by our original determinant. So x equals 1. Our -23 up here, right? This is our original determinant. So the x determinant divided by that first one. Yep. Okay, so let's set up y. So the x needs to go back to a 3, 1, 1. This time the y's get replaced with the 9, -5, and -2 constants. And z is 1, -2, -4. Then I'm going to do the repeats to connect 3 diagonals. And then again, I will let you work and let's see if our numbers can all match out. Okay, so I multiplied that to 68, -18 and -2. Those added to 40 on the bottom. The multipliers were -5, 12, and -36, and all that added to -29. Matched. So determinant y equals the down 40 subtract the -29 up, which makes positive 69. Therefore, y would equal this determinant divided by the original determinant, which is -3, right? Okay, last one. So 3, 1, 1 is the x originals, -2, +2, and 1 for the y's. This time replace the x column with the 9, -5, and -2. Okay, do your repeats. Find your 3 connectors. And then I'll let you get your numbers on your own. Okay, here's my multiplier numbers. -12, 10, 9 on the bottom. Adds to 7. Top multipliers are 18, -15, and 4. Adds to 7. So the determinant of z equals the down subtract the up, which is 0. So z equals this determinant divided by the original determinant, which is going to be 0.